To verify Ohm's law, a student connects the voltmeter across the battery as shown in the figure. The measured voltage is plotted as a function of current and then the following graph is obtained. If V0 is almost 0, identify the correct statement. So in this circuit, the total resistance will be the internal resistance plus R, where we have assumed the small r is the internal resistance. We also assume that E is the EMF of battery. So therefore, the current in the circuit will be E divided by small r plus capital R. Now when the current in the circuit is 0, voltmeter reading will be the EMF. And as we can see from this graph, when the current is 0, the voltmeter reading is 1.5 volt. That means E equals to 1.5 volts. Now, when the voltmeter reading is 0, that means the potential across the battery is 0. So we can write E minus IR equals to 0 when the voltmeter reading is 0. Now putting the value of I, E minus E upon R plus R into R equals to 0. This gives R plus capital R minus small r equals to 0. That is, capital R equals to 0. So in this case, total resistance equals to the internal resistance only. So we have current equals to E by small r. As we can see from graph, when the voltmeter reading is 0, the current in the circuit is 100 milliampere, that is 1 ampere. So this equals to 1 ampere. Putting the value of E, we get 1.5 divided by R equals to 1. Therefore, internal resistance is 1.5 ohms. Now let us see the options. The first option says the value of the resistance capital R is 1.5. This is incorrect as we have found the value of R is 0. The next option is the EMF of the battery is 1.5 volt and its internal resistance is 1.5 ohms. This is correct as we have found the EMF of battery is 1.5 volt and the internal resistance is 1.5 ohms. The third option says the EMF of battery is 1.5 volt and the value of capital R is 1.5 ohms. This option is partially correct because the EMF of battery is indeed 1.5 volt but the value of capital R is not 1.5 ohms, it is 0 ohms. The fourth option is the potential difference across the battery is 1.5 volt when it sends a current of 100 milliampere. We can see from graph that when a current of 100 milliampere is running through the circuit, the potential difference across the battery is 0 and not 1.5 volt. So the fourth option is also incorrect. So our answer is option 2.